Welcome to today's webcast. Topic is data ingestion patterns in AWS. As you can see on the screen, the audio is available through your computer. Hopefully everyone is connected and can hear. With that, let's just jump into the webcast. So we have an interesting agenda today. We'll start with some quick introductions, introduce ourselves, Thorogood, and some of the topics we'll talk about today. From there, we'll go to a description of the topic called Data Ingestion Framework. We'll move then to some more practical after starting with the theoretical by talking about considerations for choosing tools to use in the Data Ingestion Framework. In particular, we'll hit on some AWS-specific topics and tools, and we'll wrap it up for the day. So like I said, we'll start with some introductions. My name is John Miller. I'm a data and analytics consultant at Thorogood. I'm based out of our Philadelphia office, and I'm joined today by my colleague Harpreet. We're very interested in data and analytics solutions. In particular, we both worked on a number of initiatives recently where we focused on data ingestion into and transformation within data lakes. We found this topic pretty interesting, and we're here to share some thoughts on it. As far as Thorogood is an independent specialist data and analytics consultancy with a focus on data engineering, data visualization, and data science. We offer services through the breadth of data and analytics space, so everything from application design and development to architecture design and implementation to strategy definition to hands-on advanced analytics services, all the way to user empowerment and training for the systems that we build. We operate globally. The company is based out of London, and as I mentioned, we're joining from Philadelphia. We also have offices in Boston, Singapore, Sao Paulo, and Bangalore. As far as technologies, I haven't included an exhaustive list, but I've put up some that we work with most commonly. We work across many of the major technology providers in this space that you'll recognize on the screen, and many of the common cloud platforms that we see organizations using and different cloud tooling, as well as the number of different visualization tools. We're an independent consultancy, meaning that we're not tied to just one specific technology. Rather, we have experience with technologies across the entire data and analytics space so that we can understand the business goals from our customers and help make sure we're applying the right tools and techniques to identify the optimal solution given the business case. So now let's get into the bulk of it, and we'll start talking about the data ingestion framework. First, let's start off with what a data ingestion framework is. If we think about it as a whole, what might come to mind is that we're moving something from a source to a target, which is exactly what we're trying to do here. The source might be varied. There might be transactional data within our organization. We might be bringing in third-party data about the market or other important factors for our business. We might have some real-time data or even social media data as well. If we think about what that data looks like when we're connecting to it in these systems, it's pretty raw, right? It's not prepared for the end reporting goals. It's not going to be ready for any of the data analysis that we're going to be doing later on. Rather, it's in the state that it exists within that source system. It's not clean for us in many cases, and it may exist across many different source technologies and source formats. Then as we go to the other side and think about the target, the primary focus when we're talking about data ingestion framework is ingestion into a data lake-centric or data lakehouse-centric architecture. So we probably have our mind already on something like ADLS, blob storage in Azure, S3 in AWS, or even Google Cloud Storage. Anything like that where we might be basing our data lake. And here are some general characteristics for what that target location would look like. Finally, we can take a look at this arrow between the source and target, which is where we'll be spending our time today. Trying to understand what's in the source and what we want to bring into the target, but what this arrow looks like is important. We need to know what we need to build out and what those different parameters need to be to move data from the source to the target. So to do that, let's start by thinking about the overarching data architecture. Again, we might have a number of different sources that we are trying to connect to. In general, we'll try to bring data into the data lake to reflect its state as it is in the sources. So let's call that area of the data lake raw just for the purposes of this webcast. Then after raw, we'll probably have some transformation processes that sit on top of it to cleanse and transform the data to be used downstream. And we can think of the left side that's more similar with the original state of the source data. And then as we move further along the right, it gets closer to the needs of reporting and analytics. So if we're just thinking about the data ingestion framework, The primary action there is loading the data into the raw layer. There'll also be some touching of data orchestration and enrichment of the orchestration process, but this is where the bulk of the configuration and setup will need to happen. That's where things will be occurring at a high level. Let's think about what we want out of this solution. We want it to be automated where possible. Maybe the first pass won't be perfect, but we want to make sure we have a clear direction on where we want to head so we can make more of our data initiatives streamlined in the future. We want it to be metadata driven, to programmatically give instruction to ingestion framework, to tell it how we want to ingest and what we want to ingest. We want to integrate it with our data catalog. We'll give some more details on that in a few minutes. We want to be able to understand how the ingestion framework is working in an ongoing basis, even as simple as alerts for when things are complete or fail. And finally, we want to have more considerations for the framework, but we want flexibility and interoperability, which will go a long way in making sure our solution is future-proof. So before we jump into thinking about automation, let's instead just say we're going to hire a person. We're going to put that person in a room, and they're going to be responsible for loading every piece of data in our data lake. If we just put them in a room and said, go ingest all this data, they're going to have a number of questions. So these questions could be, what data should I ingest? Where do I get it? Where in the source will I find it? What are the specific table or file names? Which technologies? How do I connect to them? Do I ingest all the data or just part of it? How frequently should I be ingesting it? The list goes on. A person is going to be asking a ton of questions. And if we're building out an ingestion framework, we need to be thinking of these same things so that our ingestion framework has answers to these questions. For that reason, we'll use something called a metadata control file to capture details to pass through to our framework. This doesn't have to be an all or nothing effort. We certainly don't need to answer all of these questions on our first go. We could probably start pretty small and just say, point to the source system if we keep all the technology consistent, maybe add a few parameters to point to different tables or files in the system, and then we'll need to pass where we want them to write the data. We can then build on this as we go along. As far as data cataloging goes, we have a few considerations here. You might be wondering if this is applicable to you today, but one of the things that we found through our work is that it's actually a lot easier to integrate the data catalog when you do it from the beginning. When you're building out an ingestion framework and building out all of these independent processes that are operating separate from the catalog, with your intent to go back later and tie that catalog back in, the mountain of technical debt that you've built up and trying to tie this back in is just going to greatly increase the complexity. Once you have it in place, on the other hand, there's not really much additional overhead for new data initiatives that are planning to use the data catalog. So if you don't have it set up, each new time someone wants to bring in a different source, they're going to need to populate some of their information for the catalog so it can be tied in. And it's likely that some of these initiatives are just going to forgo using the catalog and making any effort of using a catalog kind of worthless. So instead, if you can automate all of this up front and make these things closely integrated, you're reducing the barrier to entry for working with the lake in the future. Finally, we want to think about interoperability of the catalog with other components of the architecture. Catalog is really only as valuable as the information that we can read back out of it, not what we can put into it. So when we bring all this together, we might start with an orchestration tool that reads from the metadata control file. That will tell us that we want to move some data from the source to the data lake. Once that's complete, maybe we want the orchestration file to tell the data crawler that it needs to go through the data lake to understand what data exists there and write that back to the data catalog. We'll also then want to make sure we have some monitoring and alerting processes set up to run throughout and give some notifications upon completion. After that, you might want the orchestration tool to then kick off some data transformations. Again, that'll interact with our data lake, running the crawler to update the data catalog, and then again, integrating with monitoring and alerting. That's really a high-level summary there of what the ingestion framework could look like in our minds and how all these different pieces sort of tie together. So now let's think about some of the considerations around tooling. So the first one is about people. Let's think about who will be using this. Are we more comfortable in low code or code first situations? Are we aligning our capabilities today and our intended capabilities of the future with the solution that we're selecting. The second is on organizational data architecture. So what are the key tools used throughout the organization, and not just those touching the data lake today? Are there any source systems that people are going to want to bring into the data lake in the future? Are there different special analysis tools that people are using currently that are going to need to be connected to the data lake later on? Thinking about how these tools interoperate within your data architecture is an important consideration to make. Similarly, on flexibility and customizability, of all the functionality that I need now or might need in the future, is all that built into the tool set I'm selecting? How easy is it to extend the solution to the needs of the future, which is where the challenge ends up being, because it's pretty difficult to understand what the needs of the future are just yet when you're still making that selection. So it's important to consider how flexible and customizable the tool set is that you're picking for your solution. And this leads then to this discussion of security and maintainability and cost. Is my ingestion framework compliant and secure? How easy is it going to be for my team to maintain the solution? How much is this going to cost me? And how can I maximize my investment? And finally, a point around organizational cloud strategy. Are we narrowing on one cloud provider? Are we thinking about a multi-cloud approach using open source tools? How easy is it to change and integrate other tools in the future? So with some of these considerations in mind, I'll now hand it over to Harpreet to talk through some of the available tools in AWS.
So now we'll begin talking about some of the tools within AWS that can handle some of the considerations that John just laid out. So on the screen here are some high-level sampling of tools that do the things that we have been talking about. Starting with the first topic, which is data movement. So within here, we have AWS database migration service, which basically allows you to move between databases. So you can move into like Amazon RDS and different Amazon services. We have AWS data pipeline. This helps move data between different AWS compute and storage services. There's AWS Glue. It's a serverless data integration service. We have Snow family, which allows you to move from on-prem into the cloud. AWS Data Sync, and then Amazon Kinesis Data Firehose, which allows you to capture, transform, and store streaming data. In terms of data transformation, again, we can use AWS Glue. It's a tool that can be used in various different ways. We have Amazon EMR. This uses EC2 clusters for compute, which allows for more complex transformations and also the utilization of Spark. There's AWS Batch, AWS Lambda, which is another serverless compute where you can just write code and you can deploy it, and you can use this for data transformation. In terms of data orchestration, we can use the native AWS step functions, which is integrated with all of the different AWS services that are offered. And you can also use something that's a little bit more open source, which is Apache Airflow. The benefit of using the managed workflows for Apache Airflow within AWS is that AWS actually takes care of all of the compute and the scalability of Airflow. So it's something that you worry more about actually building up your orchestration rather than worrying about the compute. So AWS takes care of all of the backend for this one. And moving forward for data cataloging, again, you can use AWS Glue Data Catalog, which uses a crawler, which you can set up, and you can basically go through all your different buckets and your storage, and you can get all of the metadata information about your tables into this data catalog, and then AWS Lake Formation as well. So this was just a high-level summary of some of the tools that are available. There are much more tools available than these, but these are the more popular ones for each of the categories listed here. There are more options beyond the native tooling, so going beyond like the AWS services. So here for more open source tooling, we can use, again, Apache Airflow, Apache Atlas, and Apache Kafka. There's also third-party tooling like Databricks, Alteryx that we can integrate within AWS, like Databricks for data transformation, data engineering, and also if you want to run some machine learning models on top of the data that you have. And you can also build your own data catalogs and orchestration tools using other tools that are also that can be connected. So here's the diagram that John showed earlier, and now we'll just kind of bring it all together, and we'll use some of the AWS tools that I've mentioned before to kind of show how a setup like this will look in a actual environment. So here we have some of the AWS tools that we were talking about listed, and we'll just kind of go through the flow and talk about how everything is connected and how it's working. So again, everything is being driven by a metadata control file. Here it could be located in some sort of S3 bucket, and we're using AWS Lambda to kind of read that file and pass on the parameters of that file to our step functions. So here, step functions is our data orchestration tool, and it's doing three things here. One is it's using the glue crawler, it's calling that, to basically crawl our files and build our catalog. It's using data pipeline to move some files from a source system to S3, and it's also using glue to do some sort of transformations to those files and then move those to S3. So it's using Glue's picking up the files that they might have been moved from the source, transforming them, and then loading them back over to S3 into a different folder or bucket. And on top of that, we also have down here Amazon EventBridge and SNS, which are some monitoring and notification services. So EventBridge, through EventBridge, we can monitor if our services run successfully or not, or we can look at the logs. With SNS, we can get notifications. So if something fails, we can get an email alert, which allows us to go and investigate what might have gone wrong. Apart from that, we can also replace our AWS Glue with something that we were talking about, like Databricks. So with Databricks, it allows us to do some more complex transformations, as well as use Spark to increase performance. So we can replace our transformation tool with something like a third-party tool called with Databricks. The only difference would be we would just have to call it using another Lambda function. So we would have a Lambda function on top of, instead of calling Glue directly, we would use a Lambda function to kind of call Databricks, and then that will run our transformation jobs. So as you can see, some of these tools that we have can be interchangeable with other similar tools that do the same job. It just depends on the complexity of the task and what needs to be done. Now I'll showcase a little demo, kind of a simplified version of a similar flow, which kind of just shows how we can bring everything together and use this. Here, I just wanted to highlight this. First, this is the metadata file that we will be using. So as we were saying, a file is basically driving everything. Here we can see that this file only has a couple of columns. We have a source location, destination location, file name, and then a load flag, and then source system, which tells us where our source location is. So its load flag is basically going to drive whether or not we want to load this file into this destination location, or we want to copy it into the destination location. So our goal here is copying a file into a destination location from a source location. Here we have our tree. For simplicity purposes, I'm using one bucket and just folders within. So here I've loaded our CSV file, that is our metadata file. I have our landing raw folder, which has our initial file, our process folder, which where the copied file will be. And here I'll go into step functions. So here is our step function that we have created. As we can see, we start our step function. First, we call the Lambda. We invoke the Lambda function. This Lambda function basically reads our metadata file, gets the parameters, and then passes it on. So here we have a choice state, which is basically looking if the load flag is 1. If it's 1, we want to copy the object, and we pass on the source and destination location parameters to this state. And if it's 1, it copies the object, and then our step function is finished. If not, it'll just pass. So this way, we're not spinning up extra resources or doing more than we need. So if our load flag is 0 for 5 and for 5 rows, and then 1 for 1, we're only copying the 1, and each time we're kind of just passing it. So we're not spinning up extra resources that we need or doing more than we need. So I'll just quickly run this to show how this works. So exit from here and starting execution. And here we can track our event history. So this tells us what's in progress, if it has succeeded or failed. And also it'll show us which path it's taken. So we can see that everything is green, so we have succeeded. So it first invoked the Lambda function. It checked if the load flag was 1. It was 1, it copied the object. And then it finished. And here we can also see our event history. If we go back into our bucket, we can see in process that, let's reload. We can see that the file has been copied over successfully, so it did what we intended to do. So yeah, so this was just a quick simplified version. As you can see, as we were showing in our slides before, that there's much more that can be done. It doesn't have to be as simple. More well thought out, which actually calls on more AWS services and does what needs to be done. Thank you all for joining us. If you guys have any questions, you can either put them in the chat or you can reach out to us.